All right, you guys, we should be looking moving due to convection and mantle. This is the first set of notes for E3.3-6, which says explain why tectonic plates move using the concept of heat flowing through mantle convection, coupled with the cooling and sinking of aging ocean plates that result from their increased density. Excuse me. So as you watch this, this is another Khan Academy video. We're just sort of mixing these up because they are some very good videos. I like the diagrams in them. Plus, it's also a change from my voice or Mr. A's voice. Just a little something different. But please draw these diagrams that are being drawn for you. Use these videos just as you should be using ours, where you're maybe reviewing them, you're stopping them, starting them, pausing them. You can go backwards. You can move ahead, forward. Please jot down questions in the margins here if you have them on your notes. Email questions to Mr. A or myself. Please be an active note taker as we get back into things here after break. Again, on the diagrams, make sure you are doing the things that you're supposed to be doing. Okay? I'm going to connect you up with the video.
What I want to do in this video is talk a little bit about maybe why the plates are actually moving in the first place. And nothing I'm talking about this video has been definitively proved. This is just kind of the current thinking, the leading thinking on why plates are actually moving, although we haven't seen the definitive evidence yet. And there's probably a combination of a bunch of things. Now, before we even talk about plates, let's just talk about convection. And you might already be familiar with the term, but just in case you're not, let's do a little bit of review of convection. So let's say I have a pot over here. So that is my pot, and it contains some water. So I have water in my pot, and let's say I only heat one end of the pot. So I put a flame right over at that end of the pot. So what's going to happen? Well, the water that's right over the flame is going to be warmed up more than any of the other water. So this water is going to get warm. But when it gets warm, it also becomes less dense. When you have a fluid, if you warm it up, the molecules are vibrating more. They have more kinetic energy. They're going to bounce further distances away from each other. They will become less dense. And if you have something that's less dense and it's surrounded by things that are more dense, and we're dealing in kind of a fluid state right here, that warm, less dense water is going to move upwards. It is going to move upwards. Well, when it moves upwards, something has to replace it. Something has to replace it. So you're going to have cooler water from this side of the container, kind of replacing where that water was. Now, this water, as this water rises, what's going to happen to it? Well, it's going to cool down. It's going to get further from the flame. It's going to mix with maybe some of the other water, or transfer some of its kinetic energy to the neighboring water. So it'll cool down. But once it cools down, what's it going to want to do? Remember, in general, the closer you are to the flame. So the water closer to the flame in general is going to be warmer. So all of this stuff is going to be warmer. And all of this stuff up here, like the coldest water, is always going to be furthest from the flame. And so it's going to be, the coldest water is going to be over here. But remember, the coldest water is also the densest water. So this water over here is dense. And so it will sink. It's denser than the water around it. And it also helps replace the water that's going here to get warmed up again. And so what you do is you have this cycle here. Warm water rises, moves over to the right down here, and then goes back down as it cools down. And it's dense, and then it gets warmed up again. And so this process essentially what it's doing is it's transferring the heat. It's allowing the heat to be transferred from this one spot throughout the fluid. And so we call this process this is convection. This is convection. Now, the reason why we think the plates are moving is because we think that there are similar types of convection currents in the asthenosphere, in the mantle, in the more fluid part of the mantle. Remember, the mantle, most of the mantle is kind of this. You can kind of view it as this mushy, spongy, not quite liquid, but not quite solid state, kind of plastic. It can kind of mush past. It can kind of flow like super, super, super thick. I guess you could call them, like super viscous fluid. So not quite solid, not quite liquid. But the same thing could be happening. You have certain areas in the mantle that are hotter than others, and this particular in the asthenosphere. And those areas, that's where you're going to have the material in the mantle move up. because it's hotter, it's less dense, and it will move up. And maybe it'll cause one of these divergent rifts where where kind of plate material and crustal material is forming. And then as it moves up, it cools down, it cools down, it cools down, and eventually sinks. And eventually sinks, only to get heated up again. So it has these kind of circular motion, just like we saw with the boiling water. And so that process, remember, this isn't completely liquid, so it is rocky. So it's going to potentially be able to take other things with it. It could maybe drag the crust along with it, and that would cause that, or I should say, it could drag the lithosphere along with it, not just the crust. It could drag all this rigid rock up here along with it, causing it to move in that general direction. So you have the drag there. You could also imagine that there's kind of a suction effect where if you view it as a fluid, you have a bunch of fluid coming down here. So it would kind of pull the lithosphere down at those points, and it would kind of push the lithosphere up. It would push the lithosphere up at those points. So you have these convection currents. You have these convection currents that are essentially driving. And these aren't going to be super fast moving fluid convection currents like you would expect with boiling water or with heated water. These would be slow moving convection currents, but they're moving enough, and they're able to kind of put enough drag on the lithosphere to take the lithosphere along with it. And so that's kind of at a high level the dominant theory as to why they're moving. There's other ones that talk about maybe the lithospheric plates. They're kind of they thicken as they move further away from this area where the ridge is forming. And if we look at this oceanic crust right over here, and so over time they're denser over here because there's more cool down material at these points, and it's already a little bit lower because this is where a lot of the land is being created, and so there's maybe some gravitational effects. But the dominant effect, we think, is due to this convection in the upper mantle.